Out there in the vast expanse of the cosmos, where stars are born and galaxies collide, there exists a celestial marvel so strange it almost looks impossible, a galaxy shaped like a perfect, glowing ring. Picture this, a colossal circle of stars millions of light-years wide, spinning gracefully through the void, its center almost empty, as if something had punched right through it. These are ring galaxies, some of the most mysterious and breathtaking structures in the universe. But here's the thing, they're not just beautiful, they hide secrets that defy everything we thought we knew about how galaxies work. Today, we're going on a journey to uncover 30 of the strangest phenomena lurking within these cosmic rings. Some of them will make you question reality. Others might leave you staring at your screen, wondering how such things could even exist. Like the bizarre black holes that orbit these galaxies like invisible predators, or the unexplained ghost stars that flicker in and out of existence without warning. And then there's the mind-bending truth about what really happens when galaxies collide, because these rings aren't just born from chaos, they thrive in it. So if you've ever looked up at the night sky and felt that tug of curiosity, that need to understand the unknown, then you're in the right place. Because by the time we're done, you won't just see these galaxies as distant lights in the dark. You'll see them as living, evolving puzzles, each one holding clues to the greatest mysteries of the cosmos. And trust me, by the end of this journey, you'll never look at the universe the same way again. So let's dive in, because the strangest wonders of the ring galaxy are waiting. At first glance, a ring galaxy seems almost too perfect to be real. A flawless cosmic halo suspended in the darkness, its stars tracing a circle so symmetrical it looks like it was drawn by an invisible hand. But nature rarely creates perfect shapes, especially in the chaotic sprawl of the universe. So how do these galaxies achieve such impossible geometry? The answer lies in violence. These stunning rings aren't born from quiet cosmic processes, they are forged in the aftermath of a galactic train wreck. Picture two galaxies hurtling toward each other, their stars, gas, and dark matter swirling in a chaotic dance. When the smaller one punches straight through the heart of the larger galaxy, something extraordinary happens. The collision sends shockwaves rippling outward, compressing gas and dust in a circular wave, like dropping a stone in a pond and watching the perfect rings expand. That wave triggers a frenzy of star formation, lighting up the edges of the expanding ring while leaving the center eerily empty. The result, a celestial bullseye. But here's the catch, this phenomenon is vanishingly rare. Most galactic collisions leave behind mangled, irregular shapes, twisted spirals, fragmented tails, or bloated elliptical blobs. For a perfect ring to form, the collision has to be a precise, needle-threaded strike. The smaller galaxy must hit the larger one dead-on, like a bullet passing through a target without tearing it apart. Even then, the ring's perfection is fleeting. Over millions of years, gravity tugs at the structure, warping it into something more asymmetric. That's why spotting one of these cosmic rings feels like catching a magician mid-trick. You're witnessing a fleeting moment of balance in a universe that thrives on disorder. And that's what makes these galaxies so mesmerizing. They're not just beautiful accidents, they're cosmic lessons written in starlight. Every perfect ring whispers the same truth, that even in the vast, unruly universe, there are moments when chaos and precision collide, leaving behind something breathtaking. One of the most baffling features of ring galaxies is what isn't there. Stare into the heart of these cosmic circles and you'll often find nothing. No dense cluster of stars, no glowing nucleus, just an eerie void where a galaxy's core should be. It's like cutting a slice from the center of a tree only to discover it's hollow. So where did the core go? Astronomers have wrestled with this mystery for decades, and the answers they've uncovered are even stranger than the emptiness itself. One leading theory suggests these cores didn't vanish, they were violently evicted. When a smaller galaxy plows through a larger one to form the ring, the collision can act like a cosmic slingshot. The immense gravitational forces might fling the central supermassive black hole, along with surrounding stars, clear out of the galaxy entirely. Imagine swinging a bucket of water in a fast circle. The water stays in until you slow down, but if you release at just the right moment, it goes flying. That could be happening on a galactic scale, with black holes hurled into intergalactic space at speeds topping 2 million miles per hour. Telescopes have even spotted what might be these runaway, nuclear, lonely supermassive black holes drifting through the void, trailing faint streams of stars like cosmic breadcrumbs leading back to their abandoned rings. But there's another possibility. Maybe the core isn't missing at all. Some researchers argue dense dust clouds left over from the collision could be shrouding the central black hole, blocking its light from our view. It's the universe's ultimate magic trick, hiding an object billions of times the sun's mass right in plain sight. Infrared observations have found hints of hidden activity in these empty centers, like heat signatures suggesting furious star formation or black hole feasts happening just out of sight. Then there's the most unsettling idea of all, that some ring galaxies never had cores to begin with. A handful of these structures appear too pristine, too symmetrical, as if they formed from some unknown process that bypassed the usual galactic rules. Could there be an entire class of galaxies that defy our understanding of how celestial structures evolve? Every time we think we've solved the missing core mystery, these cosmic rings find new ways to surprise us. They're not just challenging what we know, they're revealing gaps in our knowledge we didn't even realize existed, and that's what makes them so thrilling. Each hollow center isn't an absence, it's a question mark written in starlight, daring us to look deeper. While the emptiness at the heart of ring galaxies leaves us puzzled, the blazing brilliance of their outer rings is just as mesmerizing. Some of these cosmic halos aren't just peaceful circles of stars, they're explosive stellar factories, churning out new suns at a rate that dwarfs our own Milky Way's quiet pace. Astronomers call these starburst rings, and they're among the most energetic places in the universe. But what turns these serene-looking rings into celestial fireworks displays? The answer lies in the same violent origins that shaped them. When galaxies collide to form a ring, the shockwave from that impact doesn't just reshape the galaxy, it supercharges it. The force of the collision sends vast clouds of gas and dust crashing together, compressing them so tightly that they ignite like cosmic tinder. Suddenly, conditions become perfect for star birth on an epic scale. Imagine squeezing a handful of snow into a tight ball. The pressure alone can turn it to ice. In these rings, gas clouds collapse under their own gravity, fragmenting into thousands of dense knots, each one a potential star in the making. But here's what's truly staggering. Some of these starburst rings produce stars hundreds of times faster than normal galaxies. Take the famous Cartwheel Galaxy, for example. Its ring, stretching over 150,000 light-years, sparkles with clusters of young, blue-white stars, each one a searing beacon no older than a few million years. That's a blink of an eye in cosmic terms. These newborn stars aren't just bright, they're enormous, many times more massive than our sun, burning fiercely and dying young in spectacular supernovae that seed the ring with even more raw material for future stars. What's fascinating is how these rings act like cosmic petri dishes, revealing the secrets of star formation in extreme environments. Normally, stars form in the spiral arms of galaxies where conditions are relatively stable. But in starburst rings, everything is amplified gravity, turbulence, radiation. This lets astronomers study star birth in overdrive, watching as shockwaves trigger chain reactions of stellar creation. Some rings even develop intricate patterns with star-forming regions spaced like beads on a necklace, hinting at hidden rhythms in the chaos. Yet for all their brilliance, these rings are fleeting. The very stars they birth will eventually disrupt the delicate balance, Supernova and stellar winds blow away the remaining gas, starving the ring of its fuel. Within a few 100 million years, the fireworks fade, leaving behind a quieter, older galaxy. That's why these starburst rings are more than just dazzling light shows. They're snapshots of a galaxy's most transformative moment, a fleeting era when destruction gives way to creation on a scale almost too vast to imagine. And with every one we study, we're reminded that even in the cold depths of space, there's a fiery pulse of life. Among the many mysteries of ring galaxies, perhaps none is more perplexing than the gravitational ghosts lurking within them, dark matter that refuses to behave the way it should. These cosmic rings don't just defy expectations with their shape, they're rewriting the rules of how dark matter, the invisible scaffolding of the universe, is supposed to interact with galaxies. Normally, dark matter cloaks a galaxy in a massive, diffuse halo, anchoring stars in place with its gravitational pull. But in ring galaxies, something's off. The distribution of this shadowy substance isn't just uneven, it's outright bizarre, as if the collision that created the ring also scrambled dark matter like a cosmic mixer. Take the case of Hoag's object, one of the most famous ring galaxies ever discovered. When astronomers mapped its gravitational influence, expecting to find the usual dark matter halo, they were stunned. Instead of a smooth, spherical distribution, the dark matter seemed concentrated in the ring itself, with startlingly little in the center. It's like finding a donut where all the weight is in the sugary glaze with nothing in the middle. This flies in the face of everything we thought we knew about how dark matter behaves. After all, dark matter is supposed to be sticky. It shouldn't just follow the gas and stars when galaxies collide. Yet here we are, staring at rings where the invisible stuff appears to have been dragged along for the ride. But the plot thickens. Some ring galaxies show the opposite problem. Regions where the visible matter can't account for the gravity at all, suggesting dark matter is hiding where it shouldn't be. In the antennae galaxies, a pair colliding to form a nascent ring, there are pockets of space where stars move too fast for the visible mass to hold them. The only explanation, dark matter clumps, invisible anchors pinning stars in place like unseen hands. Yet in other rings, like NGC 7020, the stars orbit exactly as you'd expect without any dark matter at all. It's as if the collision ejected the dark matter entirely, leaving behind a ghostly imprint of where it once was. What does this mean for our understanding of the universe? For decades, we've assumed dark matter is cold, slow-moving, and passive, a silent partner in galactic evolution. But ring galaxies are showing us it might be far more dynamic. Some theorists suggest these collisions could be exciting dark matter particles, making them behave in ways our models never predicted. Others propose that dark matter might interact with itself through unknown forces, clustering or scattering in response to violent events. Every strange gravitational quirk in these rings is a clue, hinting that dark matter isn't just a backdrop to the universe's story. It might be an active player, shaping galaxies in ways we're only beginning to glimpse. And that's the real magic of these galactic oddities. They're not just challenging our assumptions, they're offering a front-row seat to dark matter's secrets. With every ring galaxy we study, we're peeling back another layer of the universe's greatest mystery, one gravitational anomaly at a time. Just when you thought ring galaxies couldn't get any stranger, the cosmos throws us another curveball: galaxies with not one but two perfect rings. These cosmic bullseyes, known as double-ring galaxies, are so rare that spotting one feels like finding a ripple frozen mid-splash. The outer ring might span hundreds of thousands of light years, while the inner one sits nestled inside like a celestial halo within a halo. But how does something so intricate, so impossibly precise, emerge from the chaos of galactic collisions? The answer might rewrite our understanding of how galaxies evolve. One leading theory suggests these double rings are cosmic echoes, evidence of not one, but two catastrophic collisions. Imagine a smaller galaxy slamming through a larger one, creating the first ring. Then, millions of years later, another interloper strikes at a slightly different angle, sending a second shockwave rippling through the already disrupted galaxy. The timing would have to be perfect, like dropping two pebbles into a pond at just the right intervals to create overlapping circles. Some astronomers point to galaxies like NGC 2994, where faint distortions in the outer ring hint at a second, later impact. But here's the twist. These secondary collisions don't just add a ring, they can warp the first one, stretching it into an oval or even breaking it into arcs. That's why pristine double rings are so rare. They're cosmic house of cards, balanced precariously between creation and destruction. Yet collisions might not be the only way these structures form. Some double-ring galaxies show no signs of a second impact. Instead, their inner rings glow with the blue light of young stars, while the outer rings are older and redder. This suggests a different process entirely: resonance. Just as Saturn's gravity sculpts gaps in its rings, the gravitational tug of a galaxy's central bar or spiral arms could herd gas and stars into two distinct wave patterns. Over time, these waves compress material into concentric rings, each one a snapshot of the galaxy's hidden rhythms. The stunning galaxy NGC 1097 even has a faint third ring, like grooves on a vinyl record, each one tracing a different harmonic in the galaxy's gravitational song. But the real enigma is how these rings survive. Gravity should tear them apart, yet some double rings persist for billions of years. Simulations reveal a possible clue. Dark matter might act as a stabilizer, its invisible fingers gently shepherding stars and gas to maintain the ring's symmetry. Other models suggest magnetic fields threading through the galaxy could play a role, creating cosmic highways that channel material into these perfect loops. Whatever the mechanism, these galactic doubles are more than just curiosities. They're masterclasses in cosmic balance, and that's what makes them so thrilling. Every double-ring galaxy is a puzzle box hiding clues about the universe's most violent dances. Some might be the aftermath of multiple crashes, while others could be the work of hidden gravitational symphonies. But one thing's certain: each one challenges us to rethink what's possible. Because in a universe where even a single perfect ring defies expectations, two rings aren't just a coincidence. They're a dare from the cosmos, asking us to look deeper. Not every ring galaxy is a perfect cosmic halo. Some look like they've been twisted by invisible hands, their once symmetrical circles warped into spirals, ovals, or even jagged arcs. These distorted rings aren't just cosmic accidents. They're cosmic fingerprints, revealing the hidden forces tugging at galaxies in ways we're only beginning to understand. Take the case of the Lindsay-Shapley ring. At first glance, it's a textbook ring galaxy, except one side of the ring bulges outward, as if someone grabbed the edge and pulled. Astronomers traced the distortion to a nearby dwarf galaxy, its gravity gently stretching the ring like taffy over millions of years. But not all warped rings have such obvious culprits. Some, like the galaxy AM064471, show bizarre kinks and bends with no visible neighbors nearby. The culprit: rogue dark matter clumps, invisible masses drifting through intergalactic space, their gravitational fingers tugging at the ring's stars like puppeteers hidden in the dark. Then there are rings that twist themselves from within. In galaxies with strong central bars, dense lines of stars cutting through the core, the bar's rotation can send shockwaves through the ring, warping it into a pretzel-like shape. The galaxy ESO 509 G017 is a stunning example, its ring contorted into a figure 8 by the relentless spin of its central bar. It's a reminder that galaxies aren't static sculptures. They're dynamic whirlpools where even the slightest imbalance can ripple outward in spectacular ways. But the most mind-bending warps come from collisions we can't even see. Simulations suggest some rings might be distorted by ancient impacts, galactic mergers, so old the intruder has long since vanished, leaving only the bent ring as evidence. Others could be shaped by gravitational echoes, relics of smaller collisions that sent vibrations through the galaxy's dark matter halo, bending the ring like a drumhead still humming after a strike. What makes these warped rings so fascinating isn't just their strangeness, it's what they reveal about the universe's hidden scaffolding. Every twist, every kink is a clue, pointing to forces we can't see but whose influence is written in starlight. And that's the real magic. In a cosmos obsessed with chaos, even imperfections tell a story. In the cosmic dance of galaxies, sometimes the most beautiful structures emerge from the most violent acts, like a ring galaxy devouring its smaller neighbor. These aren't just collisions, they're full-scale galactic feasts where one galaxy strips another apart, star by star, until only a glowing ring remains as evidence of the meal. And what's left behind isn't just a survivor, it's a transformed predator reshaped by the very act of consumption. Take the case of ARP 147, a ring galaxy locked in a gravitational tango with a smaller companion. Hubble images reveal a trail of stars, gas, and dust stretching between them like a celestial breadcrumb trail, the unmistakable signature of cannibalism in progress. The larger galaxy's gravity is peeling material from its victim, funneling it into the ring in a slow-motion avalanche of stellar debris. But here's the twist, this isn't just destruction. The stolen material fuels new star formation, turning the predator's ring into a glittering necklace of young blue stars. It's a paradox. The galaxy grows brighter, more vibrant, even as it tears its neighbor apart. The consequences of these mergers ripple across eons. As the smaller galaxy is dismantled, its dark matter halo, the invisible cocoon surrounding all galaxies, begins to merge with the larger one. Simulations show this can warp the ring galaxy's structure, stretching it into strange, asymmetrical shapes or even triggering secondary rings. Some devoured companions leave behind ghost cores, dense knots of stars that were once the heart of a galaxy, now orbiting like cosmic trophies within the ring. The galaxy UGC 4599 even shows a faint spiral structure inside its ring, possibly the mangled remains of a spiral galaxy it consumed long ago. But the most startling revelation, these mergers might be why some ring galaxies defy expectations. Normally, rings fade as star formation exhausts their gas. But cannibalistic galaxies get a constant supply of fresh fuel, stretching their starburst phases far beyond what should be possible. The Cartwheel Galaxy, for instance, shows chemical signatures in its ring suggesting it's ingested multiple smaller galaxies, each one topping up its star-forming reserves like logs thrown on a fire. What makes these events so fascinating isn't just their brutality, it's how they blur the line between creation and destruction. A galaxy eating another sounds like the end of a story. But in reality, it's just the beginning, a chaotic rebirth where old stars are recycled, new ones ignite, and the universe proves once again that even its most violent acts are just another form of transformation. And hidden in the glow of these rings is a truth all predators learn: consume enough, and eventually you become something entirely new. Some ring galaxies don't blaze with the brilliance of starbursts or warp into dramatic shapes. Instead, they whisper their presence through ghostly halos of light so faint they almost vanish against the blackness of space. These barely their rings are cosmic relics, the faded remnants of what were once dazzling structures, now clinging to existence as the universe slowly erases them. But their faintness isn't a flaw, it's a clue revealing secrets about how galaxies grow old and what happens when the fires of creation finally burn out. Take the galaxy NGC 4622 for instance. At first glance, it looks like an ordinary spiral, but peer closely and you'll spot a gossamer thin ring encircling it, barely brighter than the background sky. This isn't a newborn ring fresh from a collision, it's a survivor, a structure that's endured for billions of years as its stars scattered and its gas evaporated. The reason: galactic aging. Over time, the same shockwaves that triggered its formation now work against it. Supernova explode, stellar winds blast outward, and the ring's remaining gas, the fuel for new stars, gets blown away like smoke in the wind. Without fresh material, star formation sputters out, leaving behind only older, dimmer stars to mark where the ring once shone. But not all faint rings are dying. Some are born that way. In low-density galaxies where gas is scarce to begin with, collisions might create only wispy rings, too thin to ignite dramatic starbursts. The galaxy UGC 9625 is a perfect example. Its delicate ring glows with the soft light of aging stars, a quiet testament to a merger that never had enough material to set the cosmos ablaze. These ghost rings are cosmic echoes, their faintness a record of the universe's uneven distribution of matter, where some galaxies feast on gas, others starve. What's truly fascinating is how these fading rings interact with their environments. In crowded galaxy clusters, faint rings get stretched and shredded by tidal forces, their stars scattered into diffuse streams. But in isolation, they can persist for eons, their structures preserved like fossils in the void. Astronomers have even spotted orphaned rings, structures where the original galaxy has faded entirely, leaving behind just the ring, drifting like a celestial smoke ring. The lesson these ghostly rings teach us is profound. Beauty in the universe isn't always loud. Sometimes it's the faintest glimmers that hold the most stories. Every barely their ring is a clock ticking down the lifespan of a galaxy, reminding us that even the grandest cosmic structures are ephemeral. And in their quiet fading, they ask us to look closer, because what's vanishing today was once spectacular, and what's left behind is just as worthy of wonder. Imagine a galaxy spinning gracefully through space, its vast disk of stars rotating like a cosmic frisbee. Now picture this, slicing straight through that disk at a 90-degree angle. There's another ring of stars, gas, and dust orbiting perpendicularly, as if someone welded a giant celestial hula hoop onto the galaxy's poles. These are polar ring galaxies, some of the rarest and most baffling structures in the universe, and their very existence challenges what we thought we knew about how galaxies form and evolve. The violent origins of these cosmic oddities trace back to galactic theft on an epic scale. Most polar rings aren't born from the galaxy itself, they're stolen. Here's how it happens. A smaller galaxy ventures too close to a larger disk galaxy, and gravity takes over. The larger galaxy doesn't just pull the smaller one apart, it rips material from its victim, funneling it into a swirling ring that orbits at a right angle to the main disk. Think of it like spinning a plate on a stick, then tossing a second plate into the air so it rotates around the stick instead of spinning with the first. The galaxy NGC 4650 is a textbook example, its tilted ring glowing with the blue light of young stars, all captured from a now-devoured companion. But polar rings aren't just cosmic trophies, they're living laboratories. Their unique structure lets astronomers study two fundamental forces in isolation: gravity and motion. Normally, a galaxy's disk and its dark matter halo are aligned, making it hard to distinguish their individual effects. But in polar rings, the perpendicular orbit acts like a probe, revealing how gravity behaves at different angles. Observations of stars in these rings show something startling. They move too fast for the visible matter to hold them in place, the only explanation. Dark matter must be shaped like a squashed sphere around the galaxy, its invisible grip guiding the ring's motion in ways we're only beginning to map. What makes these galaxies even more intriguing is their fragility. Polar rings shouldn't last. Over time, gravitational tugs from the main disk should warp and eventually dissolve the perpendicular ring. Yet some, like the stunning ESO 603 G21, have maintained their structure for billions of years. The secret might lie in their dark matter halos. Some researchers suggest certain distributions could act as cosmic stabilizers, preventing the ring from collapsing. Others propose magnetic fields threading through the galaxy might play a role, creating invisible rails that keep the ring on track. Then there's the mystery of the orphan rings. A handful of polar rings show no signs of a recent collision, no shredded companion galaxy, no debris trail. One theory suggests these might be relics of ancient cosmic mergers, where the victim galaxy was fully absorbed, leaving only its rearranged stars as evidence. Another idea, they could result from extreme galactic encounters, where a near-miss interaction warped gas into a polar orbit without a direct collision. The galaxy UGC 9798 even hints at a hybrid origin. Its ring shows multiple layers, as if built over eons through repeated feasts. Polar rings don't just defy expectations, they rewrite them. Every time we find one, it's a reminder that galaxies aren't static paintings but dynamic sculptures, shaped by violence, chance, and the invisible hand of dark matter. And tucked within their perpendicular orbits is a truth as old as the universe itself. Sometimes the most profound discoveries come from looking at things sideways. Some galaxies take cosmic elegance to another level. They don't just have one dazzling ring, but multiple, each one nestled inside the other like celestial Russian dolls. These nested ring galaxies are more than just beautiful oddities. They're cosmic puzzles, hiding clues about the violent histories and hidden forces shaping galaxies over billions of years. So how does a galaxy end up with rings within rings? One possibility is sequential collisions like cosmic ricochets. Imagine a larger galaxy getting struck by a smaller one, creating that first classic outer ring. Then, millions of years later, another interloper slams through at a different angle, sending a second shockwave rippling inward. The result, a fresh ring blooming inside the original, like concentric ripples from two stones dropped in the same pond. The galaxy NGC 7020 is a textbook example, its outer ring older and redder, while the inner one sparkles with younger, blue stars, a clear sign of multiple violent encounters spaced far apart in time. But collisions aren't the only way to craft these intricate structures. Some nested rings emerge from the galaxy's own internal rhythms, what astronomers call resonance. Just as a musical instrument can produce harmonics, a galaxy's rotating arms or central bar can create standing waves in its gas and stars. These waves act like invisible cookie cutters, compressing material into precise rings at specific distances from the core. The galaxy ISO 510G70 showcases this beautifully. Its tightly wound inner ring aligns perfectly with the orbit of its central bar's rotation, while the outer ring traces the slower, grander rhythm of the galaxy's overall spin. It's celestial choreography, with gravity conducting the dance. Then there's the wild card dark matter. Simulations suggest the mysterious substance might play a role in sculpting nested rings. If a galaxy's dark matter halo is lumpy or asymmetrical, its uneven gravity could create multiple zones where gas piles up, forming rings at different distances. Some galaxies even show faint, partial rings stacked like broken halos, hinting at dark matter clumps that stirred the pot but didn't fully blend in. What makes these layered rings so fascinating isn't just their geometry, it's what they reveal about time. Every ring is a fossilized record of a galaxy's past, whether from a long-ago collision, a gravitational resonance, or an unseen tug from dark matter. And stacked together, they tell a story written in starlight of chaos, rhythm, and the invisible forces that shape the cosmos. To study them is to flip through the pages of a galactic history book, one where every ring is a chapter, and every chapter holds a new surprise. One of the most striking features of ring galaxies isn't just their shape, it's how they glow. The edges of these cosmic halos often blaze with an intense, almost electric radiance, as if someone traced the outline of the ring with a neon brush. But this isn't just cosmic decoration, it's a smoking gun. evidence of the violent forces that birthed these galaxies and continue to shape them long after the collision that created them. The secret lies in shock waves. When a smaller galaxy plows through a larger one, the impact doesn't just send stars scattering. It sends a supersonic ripple tearing through the galaxy's gas clouds. Picture the wake of a speedboat, but on a galactic scale, compressing gas so violently that it triggers a firestorm of star formation. The ring's glowing edges mark where these shock waves are most intense, squeezing interstellar gas until it collapses into newborn stars. These aren't just any stars, they're massive, blue-white giants, burning ferociously and dying young in supernova that light up the surrounding gas like a cosmic neon sign. The galaxy NGC 1291 is a perfect example. Its outer ring shimmers with clusters of these young stars, their ultraviolet radiation ionizing nearby gas and making it fluoresce in vivid hues. But shock waves aren't the only culprit. Some rings glow because they're eating. As a ring galaxy plows through intergalactic space, it can sweep up stray gas clouds, dragging them along like a snowplow gathering powder. When this gas slams into the ring's leading edge, it piles up, creating a dense, glowing ridge. The galaxy ARP 148, nicknamed Mayol's object, shows this beautifully, with one side of its ring noticeably brighter than the other, a telltale sign of its motion through a sea of interstellar material. Then there's the dark horse of the glowing edge phenomenon, magnetic fields. Simulations suggest the same collisions that create ring galaxies can amplify magnetic fields along the ring's perimeter, channeling and accelerating charged particles until they emit synchrotron radiation, a eerie, diffuse glow visible in radio wavelength. It's like the galaxy's edges are wired with invisible power lines humming with energy. What makes these glowing edges so fascinating isn't just their brilliance, it's what they reveal about the universe's feedback loops. Every newborn star, every supernova, every shock wave doesn't just light up the ring. It seeds it with heavier elements, paving the way for future generations of stars and planets. The glow isn't a static feature. It's a pulse, a sign of a galaxy constantly rewriting its own story. And in that light, we're watching the universe's endless cycle of destruction and rebirth play out on a scale almost too grand to comprehend. In the grand cosmic theater, even the most dazzling ring galaxies aren't permanent fixtures, some simply fade away. Astronomers have caught glimpses of these vanishing acts, where once vibrant rings dissolve into the darkness, leaving behind only whispers of their former glory. But what could make such a massive structure, spanning thousands of light years, simply disappear? The answer lies in a delicate dance between gravity, time, and the unforgiving physics of the universe. One of the most dramatic forces erasing these rings is sheer instability. Unlike the orderly orbits of planets around a star, the stars and gas in a ring galaxy are in constant tension. The same shockwaves that birthed the ring also left it teetering on the edge of chaos. Over millions of years, tiny gravitational nudges from passing galaxies, dark matter clumps, or even the galaxy's own central bulge can warp the ring's delicate balance. Stars begin to drift, their orbits stretching into ellipses or spiraling inward until the once perfect circle frays like a rope unraveling. The galaxy NGC 2944 showcases this beautifully. Hubble images reveal its ring splintering into disjointed arcs, as if some invisible hand is brushing it away stroke by stroke. But instability isn't the only culprit. Some rings vanish because they're too successful. Starburst rings, blazing with newborn stars, literally blow themselves apart. Each massive star lives fast and dies violently, its supernova explosion hurling gas outward at thousands of miles per second. Over time, these detonations strip the ring of the very material it needs to sustain itself, like a fire burning through its fuel. The galaxy M94 once boasted a luminous ring, but now only a faint, fragmented glow remains, scattered ashes where a stellar inferno once raged. Then there's the stealthier threat, dispersion. Rings aren't solid hoops but loose collections of stars and gas, all moving at different speeds, without a constant force to keep them aligned, like the resonant pull of a central bar or spiral arms. These stars gradually drift apart, their paths diverging until the ring dissolves into the galaxy's broader disk. It's the difference between a school of fish swimming in unison and one that slowly scatters into open water. The galaxy UGC 5797 offers a snapshot of this process mid-flight, its ring stars fanning outward like sparks from a firework. Yet some disappearing acts might be illusions. Earth's vantage point can play tricks on us. A ring seen edge-on might appear as little more than a faint smudge easily overlooked. Dust lanes in the galaxy's disk could obscure the ring entirely, hiding it in plain sight until infrared telescopes pierce the veil. Even the timing of our observations matters. Catch a ring galaxy between collisions, and it might seem like the ring is gone, when in reality, it's just awaiting the next cosmic impact to reignite its glow. What makes these vanishing rings so compelling isn't just their impermanence. It's what they teach us about the universe's relentless impermanence. Every fading ring is a clock ticking down, a reminder that even the grandest cosmic structures are fleeting. But in their dissipation, they leave behind something equally profound: the raw materials for new stars, new galaxies, and new mysteries waiting to be born. Because in space, nothing truly disappears, it just transforms, whispering its story into the next chapter of the cosmos. Among the universe's most breathtaking ring galaxies, not all follow the rules of perfect symmetry. Some wear their imperfections like cosmic badges of honor. These lopsided rings, warped into ovals, spirals, or jagged crescents, tell stories of violent origins and celestial turbulence. Their asymmetry isn't a flaw, it's a fingerprint revealing the chaos that shaped them. Take the galaxy NGC 2608, its ring stretched into a teardrop shape, one side noticeably brighter than the other. This distortion isn't random. It's the aftermath of an off-center collision, a near miss where the intruder galaxy didn't strike dead-on but instead grazed the larger disk like a bullet skimming a target. The impact sent shockwaves unevenly through the galaxy, compressing gas more intensely on one side, igniting a frenzy of star formation there while leaving the opposite quadrant quieter. The result, a ring that looks like it's been pulled sideways, its glow uneven, its structure leaning as if caught mid-stumble. But not all asymmetry comes from the initial collision. Some rings warp over time due to external forces like the gravitational tug of a neighboring galaxy. The Lindsay-Shapley ring, for example, bulges outward on one edge, its stars stretched into a faint stream pointing directly at a dwarf companion. It's a cosmic game of tug-of-war, where the smaller galaxy's gravity distorts the ring like a hidden hand pressing on a soap bubble. In crowded galaxy clusters, these distortions can become even more extreme, with multiple nearby objects pulling a ring in different directions until it resembles a twisted celestial ribbon. Then there's the invisible sculptor, dark matter. Simulations suggest clumps of this mysterious substance, unevenly distributed around a galaxy, could warp a ring's shape without any visible culprit. The galaxy UGC 5301 showcases this eerily. Its ring kinks abruptly in one section with no nearby galaxies to blame, the likely explanation. A dense knot of dark matter drifting through the area, its gravitational grip bending the ring's stars like light through a lens. What's fascinating is how these lopsided rings defy expectations. Astronomers once assumed all rings would evolve toward symmetry, their imbalances smoothed by time, but nature loves variety. Some asymmetrical rings persist for billions of years, their imperfections frozen in place by resonances or hidden forces we're only beginning to map. Others, like the galaxy AM 064471, sport rings that spiral inward like a coiled snake, evidence of internal dynamics, where the galaxy's own rotating bar or spiral arms have twisted the ring like taffy. These cosmic oddities remind us that perfection is rare in the universe. Every warped ring is a testament to the messy, unpredictable beauty of galactic evolution, where collisions aren't always precise, where forces both seen and unseen leave their marks, and where even the most violent events can create something astonishingly unique. Every cosmic detective knows the first rule of investigating ring galaxies: follow the intruder. These perfect celestial rings don't form on their own. They are born from violent collisions, where a smaller galaxy punches through a larger one like a bullet through smoke. But here's where the mystery deepens. Some ring galaxies float in perfect isolation, their suspected colliding partner nowhere to be seen. No shredded remnants, no debris trails, just the ring hanging in space like a cosmic crime scene with no culprit. So where did these phantom companions vanish to? The answers might rewrite everything we thought we knew about galactic collisions. One possibility is the intruder didn't just pass through, it got absorbed. When a small, gas-rich galaxy slams into a larger one, the collision can be so catastrophic that the victim doesn't just lose material, it gets completely dismantled. Stars from the smaller galaxy scatter like shrapnel, blending into the larger galaxy's disk until they're indistinguishable from the rest. The galaxy NGC 7222 might be a case in point. Its ring glows with unusual stellar compositions, chemical signatures hinting at stars forged in a different environment, like strangers in a crowd. These could be the last traces of a devoured companion, its identity erased but its legacy living on in the ring's very chemistry. Then there's the dark horse explanation. The intruder was never visible to begin with. Some colliding companions might be dark galaxies, clumps of dark matter with few stars, invisible to our telescopes except through their gravitational influence. Imagine a shadow passing through a lit room. You wouldn't see the shadow itself, only the way it alters the light. The galaxy UGC 4599 shows tantalizing clues. Its ring wobbles slightly, as if tugged by an unseen mass lingering nearby. Could these phantom collisions be the universe's way of showing us dark matter isn't just a passive backdrop but an active participant in galactic evolution? But the most dramatic fate for these missing intruders: ejection. Galactic collisions don't just rearrange stars, they can slingshot entire black holes and star clusters into the void at unimaginable speeds. Simulations show a perfectly aligned collision might not only create a ring but catapult the smaller galaxy's core clear out of the system. Astronomers have spotted hypervelocity objects, superfast stars, and even black holes hurtling through intergalactic space. That could be the fugitive remnants of these events. The ring galaxy AM 064471 sits eerily alone, but far beyond it, a rogue supermassive black hole streaks through the darkness at 4 million miles per hour. Coincidence or a cosmic escape artist fleeing the scene of the crash? What's haunting about these phantom companions isn't just their absence, it's what they reveal about the impermanence of cosmic structures. Galaxies aren't immortal. They merge, they crumble, they vanish into the night. And sometimes all that's left behind is a perfect ring, a silent witness to a violence so complete it erased its own cause. But look closely and the clues are there, in a star's unusual glow, in the ring's subtle warp, in the void where something massive should be. The universe never forgets. It just hides its secrets well. Among the most astonishing sights in the cosmos are ring galaxies that double as cosmic fire hoses, structures not just defined by their perfect halos of stars, but also by searing jets of material blasting outward at nearly the speed of light. These jets, stretching hundreds of thousands of light years into space, don't just add drama to an already spectacular scene. They reveal a hidden monster lurking in the galaxy's heart, a supermassive black hole in the midst of an insatiable feast. Take the galaxy NGC 6121 for example. At first glance, it looks like a textbook ring galaxy, a shimmering loop of stars against the darkness. But zoom in and two thin, ghostly beams spear outward from its center, visible only in radio wavelengths. These are relativistic jets, torrents of charged particles accelerated to within a fraction of light speed by the black hole's unimaginable gravity. The energy required to produce such jets is staggering. To put it in perspective, a single second of their output could power human civilization for billions of years. And yet, in NGC 6121, these jets coexist with the serene beauty of the surrounding ring, creating a paradox of violence and order. How does a galaxy sustain both a delicate ring and these raging outflows? The answer lies in the timing. Most ring galaxies form when a smaller galaxy punches through a larger one, triggering the iconic starburst ring. But if the larger galaxy already hosted an active supermassive black hole, one that was dormant or quietly snacking, the sudden influx of gas from the collision can awaken it catastrophically. As shredded stellar material spirals toward the black hole, it forms a glowing accretion disk heating up to millions of degrees. Magnetic fields, twisted by the disk's rotation, funnel some of this material into narrow beams along the black hole's poles, launching the jets we observe. But here's the twist: these jets can reshape the very ring that birthed them. The galaxy PKS 2058-298 offers a stunning example. Its jets plow through the surrounding gas like cosmic plows, carving bubbles and cavities in the ring's structure. In some regions, the jets even trigger secondary star formation, compressing gas as they ram through it, sparking new stellar nurseries in their wake. It's a feedback loop of chaos and creation. The collision feeds the black hole fires jets, and the jets then sculpt the galaxy anew. Yet the rarest cases are those where the jets predate the ring entirely. The Galaxy 3C296 sports a perfectly symmetrical ring, but its jets are misaligned, tilted at an odd angle to the ring's plane. This suggests the black hole was already active when the collision occurred, its jets stubbornly maintaining their original trajectory even as the galactic disk around them was reshaped into a ring. It's a cosmic snapshot of two events caught mid-conversation: the aftermath of a collision and the ongoing tantrum of a black hole that refuses to adjust its aim. What makes these jet-spewing ring galaxies so mesmerizing isn't just their rarity, it's what they teach us about the interconnectedness of cosmic phenomena. A black hole's fury and a galaxy's graceful ring might seem like opposites, but they're intimately linked, two sides of the same violent, beautiful coin. And every time we find one of these hybrid marvels, we're reminded that even in the vastness of space, nothing exists in isolation. Forces we're only beginning to understand bind everything together, from the tiniest particles to the grandest structures in the universe. Hidden within the luminous rings of these galaxies lies an invisible force shaping their destiny, magnetic fields so powerful they warp the very fabric of star formation. Unlike the chaotic magnetism of spiral galaxies, ring galaxies often exhibit organized fields that trace the curves of their stellar halos like ghostly blueprints. These fields aren't just passive observers, they're cosmic conductors orchestrating how gas collapses, how stars ignite, and even how the ring itself evolves over billions of years. Take the galaxy NGC 466, where radio telescopes revealed magnetic lines tightly coiled along its ring, pulsating with energy. Normally, magnetic fields in galaxies resemble tangled spaghetti, twisted by rotation and turbulence. But here, the collision that birthed the ring did something extraordinary. It stretched and aligned those fields into concentric loops, as if combing cosmic hair into perfect rings. This alignment isn't just aesthetic, it acts like a galactic rail system, channeling ionized gas along predetermined paths. When gas clouds ride these magnetic highways, they collide more efficiently, piling up until gravity takes over and triggers starbirth. The result: star clusters that form in orderly chains, strung along the ring like pearls on a necklace. But magnetism's influence goes beyond creation, it's also a destroyer. In the galaxy ARP 147, astronomers detected magnetic fields so intense they act like cosmic shredders. When supernovae explode within the ring, their shockwaves accelerate electrons to near light speeds, which then spiral along magnetic field lines, emitting synchrotron radiation, a telltale glow visible in radio waves. These processes can heat surrounding gas, preventing it from cooling and forming new stars. It's a paradox. The same fields that help birth stars can also sterilize entire regions of the ring, creating barren gaps where stars simply refuse to ignite. The most bizarre cases, however, are galaxies where magnetism defies gravity. In UGC 5901, the ring's outer edge is fraying not from gravitational tugs, but because its magnetic fields are literally pushing material away. Charged particles trapped in these fields create pressure strong enough to counteract the pull of the galaxy's core. Over time, this magnetic wind could strip the ring of its star-forming fuel entirely, leaving behind a skeleton of aging stars. What's astonishing is how these magnetic imprints linger long after the collision that created them. Some rings, like NGC 3303, show fields that have maintained their structure for billions of years, outliving multiple generations of stars. Their fossil records not written in stone, but in the silent, invisible forces that guide the universe's most violent dances. And every time we map one, we're reminded that the cosmos doesn't just shape matter. It electrifies it, weaves it into invisible patterns, and whispers secrets only the stars can hear. Some ring galaxies spin with a cosmic twist so bizarre it defies intuition. Their outer rings rotate backward, like a celestial clock running counterclockwise while its inner gears turn the other way. These counter-rotating rings aren't just optical illusions, they're cosmic paradoxes, challenging our understanding of how galaxies move and merge. The secret to their backward dance lies in a specific type of galactic collision, one where the intruder doesn't just pass through the larger galaxy, but slams into it from the opposite direction it's spinning. Imagine a galaxy spinning like a carousel, its stars and gas swirling in one smooth, predictable motion. Now picture another galaxy approaching not from the side, but head-on against the spin, like a reckless driver going the wrong way on a highway. When these two collide, the smaller galaxy's momentum doesn't just add to the chaos, it flips the script. The shockwave from this retrograde collision can carve out a ring that inherits the intruder's backward motion, creating a structure that spins against the galaxy's natural rotation. The galaxy NGC 4622 is a textbook example. Its outer ring whirls in the opposite direction of the inner disk, a cosmic contradiction frozen in motion. But backward rings aren't just quirks of physics, they're time capsules. Because retrograde collisions are far more disruptive than head-on strikes, they leave behind a trail of clues. Stars in these counter-rotating rings often have different chemical compositions than those in the main disk, like foreign accents in a galactic choir. They're relics of the intruder galaxy, preserved in the ring's backward spin. The galaxy ESO 509 G017 tells this story vividly. Its counter-rotating ring is rich in alpha elements, materials forged in supernova, suggesting the intruder was a smaller, star-forming galaxy that met a violent end. What's even stranger is how these backward rings resist the pull of time. Normally, friction between gas clouds in a galaxy would smooth out opposing rotations over billions of years. But some counter-rotating rings, like the one in NGC 7135, have persisted for eons. The reason? Their orbits are so precise, so perfectly balanced against the galaxy's spin, that they avoid the usual drag. It's the celestial equivalent of walking upstream without getting swept away, a delicate dance of forces that shouldn't last, yet somehow does. Yet the most mind-bending twist isn't the rings themselves, it's what they reveal about dark matter. Simulations show retrograde collisions are far more likely to produce stable backward rings if the galaxy's dark matter halo is flattened like a squashed sphere. This hidden shape steers the intruder's debris into orbits that defy the disk's spin, locking the ring into its backward motion. In other words, these counter-rotating rings might be invisible roadmaps tracing the contours of dark matter we can't see. So the next time you gaze at a seemingly ordinary ring galaxy, remember, some of them are spinning secrets. Their backward motion isn't just a curiosity, it's a cipher waiting to be decoded. And with every one we study, we're not just learning about galaxies, we're reading the universe's hidden handwriting, one retrograde ring at a time. While most ring galaxies dazzle us with visible light or radio waves, some hide an invisible secret, a faint but fierce glow of X-rays radiating from their halos. This high-energy light, invisible to our eyes but detectable by space telescopes, points to extreme environments where matter is heated to millions of degrees or particles are accelerated to nearly the speed of light. So what's powering this eerie X-ray signature? The suspects range from hidden black holes to the ghosts of dead stars, each leaving its own distinct fingerprint in the radiation. One of the prime culprits is a population of stellar corpses, neutron stars, and black holes left behind by massive stars that lived fast and died violently. In starburst rings, where star formation runs rampant, these remnants often linger like cosmic landmines. When a neutron star's crushing gravity steals gas from a companion star, the stolen material spirals inward, heating up until it emits X-rays like a celestial blowtorch. The ring galaxy NGC 7020 is littered with these so-called X-ray binaries, their glow peppering the ring like tiny, searing pinpricks. But things get even more extreme when the culprit is a black hole. In Galaxy M83, astronomers spotted an ultraluminous X-ray source in its ring, a beacon so bright it likely signals an intermediate mass black hole, a rare breed weighing thousands of suns, feasting on a hapless star that wandered too close. Then there's the diffuse X-ray haze that blankets some rings, not from pinpoint sources but from vast clouds of superheated gas. When a ring galaxy forms, the collision shock waves don't just trigger star birth, they also heat leftover gas to temperatures rivaling the sun's core. The Galaxy ARP 299 showcases this beautifully. Its X-ray glow isn't concentrated in dots but spread across the ring like a ghostly aurora, evidence of gas heated to 10 million degrees by supernova explosions and stellar winds. This isn't just leftover heat. It's a snapshot of the galaxy's energy budget, showing how much fury has been poured into the system since its violent birth. But the most enigmatic X-ray signals come from rings where no obvious source exists. The Galaxy NGC 4662 emits X-rays from its apparently empty center, with no visible black hole or star cluster to explain them. One theory suggests this could be the echo of a recoiling, supermassive black hole, one that was kicked backward during the collision, its jets now pointed away from us, while its faint X-ray glow lingers like a cosmic afterimage. Others propose these emissions might come from dark matter particles annihilating each other, a controversial idea that, if proven, could revolutionize our understanding of the universe's most elusive substance. What makes these X-ray rings so fascinating isn't just their hidden violence, it's how they force us to see galaxies in a new light. Literally, every X-ray photon is a message from the universe's most extreme environments, telling stories of matter pushed to its limits. And with each one we decode, we're reminded that the cosmos doesn't just shine, it burns. Not all cosmic rings are adorned with stars. Some drift through space like ghostly smoke rings, composed almost entirely of gas with barely a glimmer of starlight to illuminate them. These dark rings are cosmic paradoxes, structures massive enough to birth thousands of suns, yet eerily barren, as if the universe forgot to strike the match. How does a ring galaxy end up with so much raw material and so few stars? The answer lies in a delicate interplay of temperature, turbulence, and missed opportunities. Take the Galaxy UGC 1919, where radio telescopes revealed a vast hydrogen ring, dense enough to form stars, yet almost completely dark in visible light. The gas here isn't dormant, it's trapped in a catch-22. For gas clouds to collapse into stars, they need to cool, allowing gravity to overcome internal pressure. But in UGC 1919, the gas is too hot. The collision that created the ring sent shockwaves rippling through it, heating the gas to millions of degrees, far too energetic to clump into stellar nurseries. It's like trying to make snowballs with steam. Without pockets of cool, dense material, the ring remains a glowing but sterile halo, its potential forever unrealized. Yet heat isn't the only star formation killer. Some dark rings are victims of their own turbulence. In the galaxy NGC 4013, ALMA observations showed gas clouds churning violently, stirred by magnetic fields and supernova remnants from long-dead stars. This chaos prevents the gas from settling into the quiet pockets needed for star birth. Imagine trying to light a candle in a hurricane. The flame gets snuffed before it can catch. Here, the ring's gas is caught in a perpetual storm, its motion too fierce for gravity to gather it into stars. Then there's the dark horse of the phenomenon, metallicity. Stars form more easily in gas enriched with heavier elements, carbon, oxygen, iron, which act as cosmic coolants, radiating heat away. But some rings, like the one in galaxy NGC 5291, are primordial relics composed of near-pristine hydrogen and helium left over from the early universe. Without those heavier elements, the gas struggles to shed heat, remaining puffed up and resistant to collapse. It's a cosmic irony. The purest gas, untouched by generations of stars, is the least likely to create new ones. What's haunting about these dark rings isn't just their emptiness, it's their fleeting potential. Given different conditions, they could have been brilliant starburst rings glittering with newborn stars. Instead, they linger as cosmic what-ifs, reminders that even in the universe's grand design, not all raw material finds its purpose, yet their darkness isn't eternal. Some may yet awaken if a passing galaxy stirs their gas, or if a chance collision sends new shockwaves rippling through them, this time with the right balance of force and finesse to ignite the spark. Until then, they drift silently, their stories written not in starlight but in the absence of it. Some ring galaxies don't just shimmer, they shift, their colors transforming over millions of years like cosmic mood rings. What begins as a brilliant blue halo can slowly fade to gold, then red, as if the galaxy itself is aging before our eyes. This isn't just an illusion, it's a direct window into the life cycle of stars and the ever-changing chemistry of these celestial structures. Take the Cartwheel Galaxy, for example. When astronomers compared observations from decades apart, they noticed something startling. The outer ring, once dominated by the scorching blue light of young, massive stars, had taken on a softer, golden hue. The reason? Time. Those blue giants burned out fast, exploding as supernova within just a few million years, leaving behind smaller, longer-lived stars that glow with a cooler, yellower light. It's the stellar equivalent of a bustling city block quieting into a retirement community. The same structure remains, but the population has changed. But star aging isn't the only force repainting these rings. Chemistry plays a role too. When massive stars die in supernova, they scatter heavy elements like oxygen, carbon, and iron back into the galaxy's gas clouds. New stars born from this enriched material carry a different spectral signature, subtly altering the ring's overall color. The galaxy NGC 7020 showcases this beautifully. Its ring's inner edge glows pinkish red, rich with ionized sulfur and nitrogen, telltale signs of generations of stars seeding the cosmos with the elements forged in their cores. Then there's the wild card, intermittent star formation. Some rings pulse with color changes as waves of stellar birth sweep through them. The galaxy ARP 147 alternates between blue and gold as pockets of gas collapse into stars, burn out, and then, triggered by some hidden rhythm, ignite anew. It's like a cosmic traffic light, cycling between go and stop, with each phase leaving its mark on the ring's palette. What makes these color shifts so mesmerizing isn't just their beauty, it's their defiance of expectation. We often think of galaxies as static paintings, but they're more like living canvases, their hues evolving with every stellar death and rebirth. And with each tinted ring we study, we're reminded that the universe doesn't just exist, it transforms one brushstroke at a time. Some ring galaxies don't just shine, they breathe. Their brilliance swelling and fading in cycles that span years or even decades. This cosmic pulsation isn't a trick of the eye, it's a real, measurable phenomenon, as if the galaxy itself has a heartbeat. And just like a doctor listening for clues in a pulse, astronomers study these rhythmic glows to diagnose the hidden forces at work. One of the most dramatic culprits lies at the galaxy's core, quasars. These supermassive black holes, gorging on surrounding gas, can flare unpredictably, their accretion disks belching out torrents of light that wash over the entire ring. The galaxy UGC 3621 offers a stunning example. Normally, its ring glows steadily, but in 2012, telescopes caught its core flaring to 5 times its usual brightness. A surge so intense it illuminated previously unseen gas clouds in the ring, like a flashlight beam sweeping across a dark room. Months later, the glow faded, leaving astronomers to wonder, was this a one-time eruption or part of a cycle we're only beginning to map? Yet quasars aren't the only players. Some pulsing rings owe their rhythm to armies of variable stars, aging giants like Cepheids or Lyrae stars that swell and shrink in predictable patterns. The ring galaxy NGC 1291 is littered with these celestial metronomes, their combined light waxing and waning like a symphony of flickering candles. When thousands sync up, the entire ring can appear to throb faintly over years. But here's the twist, these stars don't just pulse, they drift. As they orbit the galaxy, their light echoes off dust clouds in the ring, creating secondary brightening effects that can fool telescopes into seeing phantom pulsations. Then there's the cosmic sleight of hand, gravitational lensing. When a massive object passes between us and a ring galaxy, its gravity can bend and amplify the galaxy's light like a magnifying glass. The galaxy SDSS J0946 plus 1006 seemed to pulse every 6 months, until astronomers realized its rhythm matched the orbit of a foreground star cluster, warping its light. These lensing events are fleeting, but they leave behind fingerprints, telltale distortions in the ring's shape, or colors that shift slightly as different wavelengths of light are bent at varying angles. What makes these pulsing rings so captivating isn't just their mystery, it's their impermanence. Unlike the steady glow of most galaxies, these flickering halos remind us the universe isn't static. It's alive with hidden rhythms, from the tantrums of black holes to the synchronized dances of ancient stars. And every time we catch one in mid-pulse, we're glimpsing a secret the galaxy might not reveal again for centuries. Deep within some ring galaxies, light doesn't just travel, it lingers, bouncing off cosmic mirrors to replay history like a celestial echo. These light echoes are more than just pretty reflections. They're time machines, revealing explosive events that lit up these galaxies centuries or even millennia before the light finally reached our telescopes. Imagine a supernova detonates in a ring galaxy 50,000 years ago. Its initial flash zips past us in an instant, but some of that light hits dense dust clouds in the ring, scattering and delaying its journey. When the reflected glow finally arrives today, we see it as a ghostly ring expanding outward from the long-dead star's corpse, a ripple frozen in time. The galaxy NGC 6872 offers one of the most stunning examples. In 2005, astronomers spotted an eerie, glowing arc spreading through its ring, not a new explosion, but the delayed reflection of a supernova that had actually erupted in the late 19th century. By tracking how this echo expanded over years, they could reconstruct the original blast in unprecedented detail, measuring everything from the star's final gasps to the structure of the dust clouds that caught its dying light. It's like hearing an echo in a canyon and using it to map not just the cliffs but the shape of the shout that created it. But echoes don't just replay stellar deaths, they expose hidden galactic anatomy. In the Lindsay Shapley ring, a flickering light echo revealed something unexpected. Vast sheets of dust stretching far beyond the visible ring, structures so diffuse they'd escape detection until the reflected light of a central black hole's outburst illuminated them like a cosmic flashlight. These dust labyrinths, likely debris from ancient collisions, act as galactic archives, their layers preserving chemical fingerprints from different eras. By studying how light echoes scatter off them, astronomers can read these layers like tree rings, uncovering the galaxy's turbulent past. The most mind-bending echoes, though, come from quasars. Some ring galaxies hosting active black holes show phantom flares, delayed brightenings caused by light taking different paths around warped spacetime near the black hole. The galaxy 3C2096 exhibited a bizarre double echo, two identical bursts of light arriving months apart, the second one caused by light looping around the black hole's gravitational well before reaching us. It's the ultimate cosmic replay, proving even light itself can't resist the pull of these galactic mysteries. What makes these echoes so powerful isn't just their beauty, it's their defiance of time. Every shimmering ripple is a message from the past, a reminder that the universe's history isn't locked away but still pulsing through the void, waiting for us to listen. And with every echo we catch, we're not just observing a galaxy, we're conversing with its ghosts. Among the most enigmatic ring galaxies are those that seem to defy their own name, structures so perfectly circular they could pass for cosmic cartwheels, yet marred by jagged spokes cutting across their halos like fractures in a stained glass window. These radial filaments, sometimes straight as laser beams, other times twisted like celestial lightning, transform what should be smooth rings into galactic pinwheels, spinning secrets we're only beginning to decipher. The origin of these spokes lies in the delicate interplay of forces within the ring itself. When a collision births a galactic ring, the resulting shockwave doesn't just compress gas, it sets the entire structure vibrating, like a drumhead struck by some invisible hand. In most cases, these vibrations settle into smooth orbits, but when conditions are just right, when the ring's density, temperature, and rotation reach a critical balance, instabilities arise. Denser regions begin pulling material inward along radial paths, forming transient spiderwebs of gas and dust that stretch from the ring's outer edge toward its center. The galaxy NGC 7140 showcases this beautifully. Its spokes shimmer with young stars, suggesting these filaments aren't just temporary scars but stellar nurseries, where collapsing gas gives birth to stars along these bizarre celestial highways. Yet gravity isn't the only sculptor at work. Magnetism weaves its own invisible web through these structures. Observations of the galaxy IC4522 revealed something startling. Its spokes glow faintly in radio waves, the telltale signature of electrons spiraling along magnetic field lines. Simulations suggest the original collision could have amplified the galaxy's magnetic fields, twisting them into radial patterns like iron filings around a bar magnet. These fields then act as cosmic rails, channeling ionized gas into spoke-like formations that persist for eons. It's a double-edged sword. The same forces that create these breathtaking structures also drain energy from the ring, potentially shortening its lifespan by accelerating star formation in concentrated bursts. The most bewildering examples, however, are galaxies where the spokes don't just radiate, they rotate. The galaxy UGC 12687 spins its spoked wheel like a celestial clock, with filaments that gradually curve over millions of years. This motion defies simple gravitational explanations, hinting at something deeper, resonant harmonics between the ring's rotation and the orbital periods of its stars. Picture a skipping rope swung at just the right rhythm. Certain points seem to stand still while the rope moves. Similarly, These rotating spokes may be standing waves in a galactic sea, points where the orbits of stars and gas sync up to create persistent patterns in the chaos. What makes these spoked rings so mesmerizing isn't just their beauty, it's their defiance of our expectations. They remind us that even in the grandest structures, hidden rhythms and invisible forces are at play, weaving complexity into what seems at first glance to be simple. Every spoke is a puzzle, a celestial equation balancing gravity, magnetism, and motion, and with each one we decode, we're not just understanding a galaxy. We're learning the universe's hidden language. Among the most elusive phenomena in ring galaxies is something we rarely get to witness directly: their shadows. These aren't the simple dark patches we're used to seeing from planets or moons, but vast, cosmic silhouettes cast by the ring's structure onto the surrounding gas and dust. Like a celestial sundial, these shadows reveal hidden details about the galaxy's shape, composition, and even its history, offering astronomers a unique way to map what would otherwise remain invisible. One of the clearest examples comes from the galaxy NGC 7049. Here, the ring's dense outer edge blocks light from the galaxy's core, casting a shadow so pronounced it's detectable in multiple wavelengths. The shadow isn't static. It shifts and warps as the ring rotates, creating a moving tapestry of light and dark that traces the ring's three-dimensional structure. By analyzing how this shadow distorts over time, researchers can calculate the ring's thickness, its tilt relative to Earth, and even the density of its star-forming regions. It's like watching a flashlight beam pass through a slowly turning wire mesh. The patterns of light reveal the mesh's hidden shape, but shadows do more than outline the ring. They expose the galaxy's hidden environment. In the case of the Cartwheel Galaxy, the ring's shadow falls on a vast, diffuse cloud of hydrogen gas lingering in the galaxy's outskirts. This gas, normally too faint to study in detail, lights up in silhouette, its edges sharply defined by the ring's backlight. The shadow's shape tells astronomers something startling. The gas isn't distributed evenly but clumped in filaments, likely remnants of the ancient collision that formed the ring. Without the shadow, these structures would have remained invisible, their presence only inferred indirectly. The most fascinating shadows, however, aren't cast by the ring's stars but by its dust. In galaxy ISO 359G19, infrared telescopes detected a shadow so deep it absorbs nearly all the light from the core, but only at specific wavelengths. This selective dimming points to a ring packed with microscopic dust grains, their composition subtly altering the shadow's hue like a cosmic stained glass filter. By dissecting the shadow's spectrum, astronomers identified molecules like silicates and polycyclic aromatic hydrocarbons floating in the ring, clues to the chemical soup from which new stars are born. What makes these shadows so powerful isn't just their ability to conceal, it's what they reveal. Every darkened patch is a negative image, a fingerprint of the galaxy's hidden architecture. And with each one we study, we're reminded that sometimes the most illuminating discoveries come from the darkness. Among the many mysteries of ring galaxies, some stand out not for their brilliance but for their stubborn refusal to follow the rules of cosmic expansion. Most rings spread outward over time, their edges drifting further from the center as shockwaves dissipate and stars follow the pull of gravity. But a rare few seem frozen in place, their boundaries unnaturally sharp, as if some unseen force has locked them in celestial stasis. These defiant rings challenge our understanding of galactic evolution, and the explanations astronomers have uncovered are as strange as the phenomenon itself. One leading theory points to hidden mass, not the dark matter halos we expect, but something more concentrated. Simulations suggest if a ring galaxy's collision left behind a dense knot of stars or a mid-sized black hole orbiting just beyond the ring, its gravity could act like an invisible fence, corralling the outward flow of material. The galaxy NGC 7742 may be a prime example. Its ring displays unusual stellar motions, with stars near the edge slowing abruptly, as if hitting an unseen barrier. Radio telescopes even detected a faint radio source lurking just outside the ring, possibly a black hole binary weighing thousands of solar masses, its gravitational grip counteracting the ring's natural expansion. Yet mass isn't the only explanation. Some rings might be held in place by external pressure. Imagine a galaxy swimming through a dense intergalactic cloud. The galaxy ESO 509 G098 drifts through a cluster brimming with hot gas, its ring pressing against this cosmic wind like a boat's bow wave. Normally, such pressure would distort the ring, but here, it's perfectly balanced against the galaxy's internal forces, creating a rare equilibrium where expansion and compression cancel each other out. Then there's the wild card, formation quirks. Most rings emerge from direct collisions, but a handful might form through tidal resonance, where a near-miss encounter triggers a density wave without a full impact. The Galaxy ARP 147's ring shows no signs of a recent collision, yet its stars orbit in perfect sync with the galaxy's inner bar. Like a skipping rope held at both ends, this resonance creates standing waves that resist spreading, locking the ring in place through sheer gravitational harmony. What makes these static rings so fascinating isn't just their defiance, it's what they reveal about the delicate forces shaping galaxies. Every frozen ring is a cosmic scale, balancing gravity, motion, and pressure in ways we're only beginning to measure. And with each one we study, we're reminded that even in the vastness of space, equilibrium can be as breathtaking as chaos. Hidden within the delicate structure of some ring galaxies lies an invisible rhythm patterns so precise they resemble the concentric ripples of a struck bell. These aren't visual illusions, they're cosmic sound waves frozen in starlight, revealing how gravity and motion harmonize on scales almost too vast to comprehend. Unlike the chaotic aftermath of most collisions, these galaxies hum with order, their rings segmented into perfectly spaced arcs, as if the universe itself composed a galactic symphony. The secret to these harmonic rings lies in density waves ripples that travel through the galaxy's gas and stars like sound through air. When a smaller galaxy collides with a larger one, the impact doesn't just scatter material, it sends vibrations reverberating through the disk. Imagine dropping a pebble into a pond, but instead of water, the ripples move through stars and gas, compressing them into bands where the waves' crests converge. The Galaxy NGC 3293 showcases this beautifully. Its ring divides into distinct, evenly spaced segments, each one a note in this celestial chord. These waves don't just shape the ring, they orchestrate star formation, triggering bursts of stellar birth wherever the densest regions of gas collapse under the wave's pressure. But density waves alone can't explain the most intricate patterns. Some rings, like the one in ESO 380G051, exhibit spiraling arms within the ring itself, a phenomenon akin to harmonics in a vibrating string. Here, gravitational resonances take center stage. As the galaxy rotates, its inner stars and outer ring orbit at different speeds, creating points where their gravitational pulls sync up. These resonant points act like cosmic metronomes, herding stars and gas into rhythmic formations. It's the galactic equivalent of pushing a child on a swing at just the right intervals to build momentum. Over time, these synchronized tugs sculpt the ring into elaborate subdivisions, from delicate radial spokes to nested loops that mirror the mathematics of musical intervals. What's even more astonishing is how long these patterns endure. Unlike sound waves in air which fade in seconds, galactic harmonics can persist for millions of years. The Galaxy UGC 12661 holds a record. Its ring's wave pattern has remained stable for nearly 1 billion years, a testament to the perfect balance between the galaxy's rotation and its dark matter halo's grip. This durability suggests something profound. These waves aren't fleeting anomalies but integral parts of the galaxy's structure, as fundamental as the arms of a spiral or the bulge of an elliptical. Yet the true magic lies in what these waves reveal about the unseen. By mapping their spacing and speed, astronomers can listen to the galaxy's hidden composition. Waves move faster through regions thick with dark matter, slower where gas dominates. In this way, the ring's harmonics become a diagnostic tool, probing the invisible scaffolding of the universe itself. Every ripple is a message, not in starlight but in gravity's quiet language waiting to be decoded. So the next time you gaze at a ring galaxy, remember, some of them aren't just spinning. They're singing, and in their vibrations, we're hearing echoes of the forces that shape all things from the smallest atom to the grandest structures in the cosmos. Scattered along the luminous bands of some ring galaxies, there are points of light so intense they outshine the rest of the ring compact, diamond-like knots blazing with the brilliance of millions of stars packed into regions barely larger than our solar system. These aren't just dense star clusters, they're cosmic jewels forged in the extreme conditions of the ring's violent birth. And what makes them extraordinary isn't just their brightness, it's what they reveal about how stars form under pressure. Take the galaxy NGC 1672, where one such knot in the ring outshines entire spiral arms of the Milky Way. Spectroscopy peels back the layers of this stellar gem, showing it's not a single object but a superstar cluster, a crush of newborn suns so tightly packed that if you stood on a planet inside it, the night sky would glow with the light of thousands of neighboring stars closer than Alpha Centauri is to us. These clusters form when shockwaves from the galaxy's collision slam together gas clouds with such force that they collapse into dozens, sometimes hundreds, of massive stars simultaneously. Unlike typical star clusters, which might birth a handful of heavy stars, these knots are factories for stellar giants, creating stars 100 times the mass of our Sun in a frenzy of creation. But diamonds aren't forever, at least not in cosmic terms. The same stars that make these knots shine so brightly also seal their fate. Massive stars live fast and die violently, their supernova explosions blasting away the surrounding gas that could have formed future generations of stars. In the Cartwheel Galaxy's eastern ring, Hubble spotted a knot that dimmed by half over just 2 decades, not because its stars faded, but because successive supernova cleared out its nursery, leaving behind a glittering but short-lived spectacle. It's a stellar boom and bust cycle playing out on a scale almost too vast to grasp, yet some knots defy this ephemeral nature. The galaxy M83 hosts a diamond-like region that's persisted for over 50 million years, a rarity in the fast-burning world of starburst. The secret continuous feeding. This cluster sits at a crossroads in the ring where gas streams converge, funneling fresh material into its core like a cosmic whirlpool. Instead of fading, it's grown brighter over time, its star's violent deaths offset by new births in an unbroken chain. What makes these diamond knots so mesmerizing isn't just their luminosity, it's their duality. They're both creators and destroyers, forging stars at a pace that defies the calm of our own galactic neighborhood while simultaneously tearing themselves apart. And with every one we study, we're glimpsing the universe's capacity for both beauty and fury, locked together in a single, shining point of light. Some ring galaxies don't stand alone. They stretch into the void like cosmic spiders, their luminous rings tethered to faint, thread-like filaments that vanish into the darkness. These aren't mere coincidences of perspective, they're glimpses of the universe's hidden skeleton, the vast cosmic web of dark matter that structures everything we see. And in these rare galaxies, the ring acts like a beacon, illuminating the invisible threads that bind the cosmos together. Take the galaxy UGC 5592, where the ring's western edge fans outward into a delicate tendril of gas and stars, trailing off into intergalactic space like a brushstroke on a black canvas. At first glance, it might resemble a tidal tail, the kind left behind when galaxies rip each other apart. But this filament doesn't curve or fade like debris from a collision. Instead, it runs arrow straight for nearly 500,000 light-years, connecting to a neighboring galaxy cluster like a celestial umbilical cord. Spectroscopic analysis reveals something even stranger. The stars in this filament aren't the usual mix you'd expect from a galactic wreck. They're older, metal-poor relics from the early universe, strung along this path like beads on a string. The leading theory: we're seeing a dark matter filament made visible. According to cosmological models, the universe's matter isn't scattered randomly but woven into a gigantic web, with dark matter as its threads and galaxies as its knots. Normally, these filaments are invisible, detectable only through their gravitational influence. But in UGC 552, the ring's collision may have funneled gas and stars into the filament's gravitational groove, lighting it up like neon tracing a wire. It's as if the galaxy's violent birth accidentally sprayed paint onto the cosmic scaffold, revealing a structure we'd otherwise never see. Yet some filaments defy even this explanation. The galaxy NGC 7742 boasts a ring with two opposing tendrils, each stretching into nothingness. No galaxy clusters, no visible endpoints. These ghostly strands align perfectly with predictions from dark matter simulations, where filaments intersect at slight angles, creating barren crossroads in intergalactic space. Radio telescopes have detected cold hydrogen gas flowing along these paths, as if the filaments are cosmic pipelines, channeling raw material between galaxies too faint to spot. What's breathtaking is how these structures challenge our notion of what a galaxy even is. Most models treat galaxies as isolated islands, but ring galaxies with webbed filaments blur the boundaries. They suggest galaxies might be more like ports in a vast, interconnected network, fed by hidden currents of dark matter and gas, their fates entwined with the universe's grand architecture. Every glowing filament is a clue, a flicker of light revealing the dark threads stitching reality together. And with each discovery, we're reminded what we see is only a fraction of what's truly there. Some ring galaxies don't just glow, they flicker, their light pulsing unpredictably like cosmic fireflies caught in a celestial net. At first glance, this sparkling might seem like a trick of the eye, but telescope data reveals these fluctuations are very real, raising a tantalizing question. What could possibly make something as vast as a galactic ring shimmer like a distant candle in the wind? The answer lies in a cosmic interplay of chance, physics, and the delicate dance of light across unfathomable distances. One of the prime suspects is microlensing, a phenomenon where invisible objects drifting between us and the galaxy briefly magnify its light. Imagine a rogue planet or a lone black hole passing in front of a star in the ring. Its gravity bends the star's light like a lens, causing it to brighten for weeks or months before fading back to normal. In dense stellar environments like ring galaxies, these microlensing events could happen constantly, with different stars flaring at random times, creating the illusion of a galaxy-wide twinkle. The galaxy ISO 325G004 showcases this beautifully. Hubble caught multiple stars in its ring flaring in sequence, their brightening patterns matching textbook microlensing predictions. But here's the catch: these events are rare. For a ring to flicker noticeably, it would need a swarm of free-floating lenses, far more than our models predict. Could ring galaxies be hiding populations of invisible objects, dark matter clumps perhaps, that our telescopes can't see except when they briefly lens a star into view? Yet microlensing isn't the only explanation. Some of this sparkling might come from the stars themselves. Ring galaxies are packed with variable stars, aging giants like Cepheids or Aurora Lyrae that rhythmically expand and contract, their brightness waxing and waning over days or years. In a normal galaxy, these stars blend into the background, their individual pulses drowned out by the glow of billions of others. But in a ring where star formation is concentrated in a narrow band, their synchronized flickering could become visible en masse. The galaxy NGC 7374 offers a clue. Its western arc brightens and dims by nearly 10% every few years, a pattern that matches the combined pulsations of thousands of variable stars reaching peak luminosity at the same time. It's like a stadium wave of stellar heartbeats visible across millions of light years. Then there's the wild card, observational artifacts. Earth's atmosphere distorts light, and even space telescopes aren't immune to cosmic ray strikes or instrumental noise. Some sparkling might simply be the universe's version of static random fluctuations mistaken for astrophysical phenomena. But one galaxy, UGC 1268, throws a wrench into this theory. Its flickering isn't random. The ring brightens predictably every 17 months, a cadence too precise for noise or microlensing. Intriguingly, this matches the orbital period of a suspected binary black hole at its core, hinting that the ring's shimmer might be a side effect of the monsters lurking in its heart. What makes these sparkling rings so mesmerizing isn't just their beauty, it's their defiance of easy explanation. Every flicker is a riddle, forcing us to question whether we're seeing the dance of stars, the shadow play of invisible matter, or something even stranger. And with each twinkle we decode, we're reminded the universe loves a good mystery. Among the countless ring galaxies scattered across the cosmos, a rare few defy time itself. Structures that should have dissolved into chaos eons ago, but instead glow with the stubborn vitality of celestial immortals. These enduring rings mock our expectations, surviving not for hundreds of millions of years, but for billions, outliving entire cosmic epochs while maintaining their pristine halos. Their secret, a perfect storm of conditions that transforms them from fleeting marvels into near-permanent fixtures of the universe. One key to their longevity lies in their isolation. Most ring galaxies fade quickly because neighboring galaxies tug at their delicate structures, pulling stars and gas out of alignment. But the immortal rings, like the famed Hoag's object, float in near-empty voids unchallenged by gravitational intruders. Without external disruptions, their stars follow orderly orbits, tracing the same paths for eons with minimal scattering. It's the difference between a sandcastle on a crowded beach and one on a deserted island. No waves, no footprints, just time passing silently. Yet solitude isn't enough. These rings also possess a hidden stabilizer, dark matter arranged in an unusual, flattened halo. Simulations reveal that if dark matter forms a dense, disk-like cocoon around the galaxy, it acts as a gravitational scaffold, reinforcing the ring's shape against internal turbulence. The stars within respond to this invisible framework, their motions synchronized like dancers adhering to an unseen choreographer. The galaxy NGC 7020 exemplifies this. Its ring remains razor-sharp despite being over 2 billion years old, a testament to dark matter's sculpting hand. But the true game-changer may be what's missing: gas. Counterintuitively, immortal rings often have very little free-floating gas left to fuel new stars. While this renders them infertile, it also removes the primary source of instability. Gas clouds collide, fragment, and explode, churning the galactic disk. Without them, stars move in serene, predictable arcs, avoiding the collisions and detours that would otherwise blur the ring's edges. The galaxy UGC 4599 illustrates this trade-off. Its ring is almost devoid of young stars, a ghostly circle of aging suns that have quietly orbited in lockstep for ages. Then there's the wild card, resonance. Some immortal rings lock into gravitational harmonies with their own central bars or spiral remnants, creating a self-sustaining rhythm. Like a pendulum clock that winds itself, these resonant systems constantly correct minor deviations, funneling stray stars back into the ring's embrace. The galaxy ISO 510G70 maintains its structure this way, its inner bar spinning in perfect cadence with the outer ring, a celestial metronome ticking across billions of years. What makes these eternal rings so captivating isn't just their defiance of time. It's what they reveal about balance. They exist at a crossroads of forces where gravity, motion, and chance converge to create something that shouldn't last, yet does. And in their quiet persistence, they whisper a truth about the universe. Even in a realm of constant change, there are pockets of order, fleeting only on cosmic scales where perfection finds a way to endure. From hollow cores where supermassive black holes should reign to ghostly filaments tracing the universe's dark matter web, every phenomenon we've explored in these ring galaxies defies expectation. Starburst rings glowing with newborn stars, yet devoid of gas where physics says stars should form. Counter-rotating halos spinning against their galaxy's motion like cosmic rebels. Diamond-like stellar knots blazing brighter than entire spiral arms, only to vanish in supernova explosions within mere millennia. Each discovery peels back another layer, revealing how little we truly understand about these celestial marvels. Consider the contradictions we've uncovered. Rings that pulse with quasars yet remain perfectly symmetrical, dark matter that clings stubbornly to the ring's edge instead of enveloping the galaxy, and missing intruder galaxies that should have triggered these collisions but left no trace. Even time behaves strangely here, some rings frozen in stasis for billions of years while others flicker like candle flames in a cosmic breeze. And perhaps most haunting of all, the light echoes that replay ancient supernova as if the universe itself refuses to let go of the past. What binds these 30 mysteries together isn't just their strangeness, it's how they expose the gaps in our cosmic knowledge. Every perfect ring, every warped filament, every whispering shadow forces us to reconsider the rules we thought governed galaxies. They challenge us to ask better questions. Could dark matter interact with itself in ways we've never imagined? Are we underestimating the role of magnetism in sculpting galactic structures? And if rings can form without collisions, as a few peculiar examples suggest, what other cosmic processes are we missing? The deeper we look, the clearer it becomes. Ring galaxies aren't just oddities. They're cosmic experiments, natural laboratories where the universe tests its own laws under extreme conditions. And right now, with telescopes like James Webb and the upcoming Vera Rubin Observatory, we're poised to uncover even more of their secrets. So here's the question I'll leave you with. If a single ring galaxy can rewrite our textbooks 30 times over, what other revelations are hidden in the depths of these celestial halos, waiting for the right observer, the right moment to step forward and say, "Look, there's something no one expected. The universe is speaking. All we have to do is listen." And if today's journey through these mysteries sparked your curiosity, I'd love to hear your thoughts. Which of these phenomena surprised you the most? What cosmic riddles do you think we'll solve next? Drop your ideas in the comments, because the next great discovery might just begin with a conversation.